Hello, and welcome to my video about color blindness and how we can make data visualizations more accessible to people with color blindness. So, human vision relies on two main types of photoreceptors, rods and cones are essential for color vision. And so, humans have three types of cones, and each is sensitive to different wavelengths of light, red, green, and blue. And when one of these cone types is absent or malfunctioning, it results in color blindness. So this condition is passed genetically usually, and it might also be caused by some eye diseases. However, when individuals have color blindness, they often perceive colors differently, and they have difficulty distinguishing between different colors and shades. And so this is like an image and how it would be perceived by an individual with normal vision, and these are images of how people with different kinds of color blindness would perceive this same image. And these are percentages of the population that have these kinds of color blindness. I do want to mention that these individuals have the most common type of color blindness, which is red green color vision deficiency. Which means that these individuals have a very hard time distinguishing between red and green, if not at all. So why is this important? 1 in 12 men have color blindness. That's 8% of men. 0.5% of women have color blindness. We have a total of around 300 million people in the world, around the world, who have color blindness. And we do know that many visualizations use colors like red, green, or blue to differentiate between categories, which can make it very hard for colorblind users to interpret data correctly. And we do want to make our data visualizations accessible to everyone. What can we do differently? First of all, we can use different shapes, patterns, and sizes instead of simply relying on colors. So this would be a plot that uses colors to differentiate between the densities of different species. But we can simply introduce different line types. And so here, one thing that I did is increase the size of the lines to make them more visible. But even if a person is unable to distinguish between these colors, they can see the different line types and the legend. And so you can include the line type here, and you can also set up the line types manually here. One other thing you can do is annotate your plot. So we can introduce the annotations like this here. And so you can annotate, add a segment and then add text, and you can include different multiple annotations in one plot. And so this makes it very clear to an individual with color blindness what each density plot is for. And so here, yeah, clearly we can see that a person looking at these plots does not need color to distinguish between the different species. When using geom points, we can use different shapes instead of the colors. And so we would use shape here, and we can also set up manually the shapes that we want to include. And so here we can see this one relies on the colors, but here we use different shapes, circles, triangles, and stars to distinguish between the different species. When using GeoMBar, we can use different patterns instead of colors. And so for this, you would need a GG pattern, the package GG pattern, and you would need to include pattern here and use a GeoMBar pattern with different parameters. And you can also set up the patterns manually that you want to include. Which is what we did here. You can also include the color, but it's not necessary since the patterns are pretty, they allow you to distinguish between the different categories. If you do want to use color, there are colors that you need to avoid using in the same plot, and those are red and green, yellow and violet, and then blue and green. And then if you do want to use color, there are some packages that have colors that are safe to use for colorblind individuals. And you can also use a package called Color Blind Check that allows you to visualize the palette and the colors as perceived by people with color blindness. So first, we're gonna use this Art Color Brewer package, and we can display all the palettes in this package nicely like this, and you can choose one of them that you like. But you can also display only the colorblind friendly colors palettes, and you can choose one of them to use in your plots. Spectral is one of these R Color Brewer palettes, and we can use the colorblind check package to see how this palette would be perceived by different types of color blind individuals by palette check. You can also make your own colors and not rely on one of those packages. And you would usually use the hexadecimal RGB color specification by specifying the intensity for the red, green, and blue channels. You using hexadecimals. And so here I make my own palettes with some colors. And I use this palette check from the colorblind check package to see how this palette that I made would be perceived by different types of colorblind individuals. And I can definitely see that this might be a little bit problematic for colorblind individuals because these colors could be confused together. Now, whether you make your own palettes or you choose one from our color brewer, this is how you add it to your plot. So I have a plot here, and I can, if I'm using a palette that I constructed manually, I use scale fill manual with the palette. And if we're using a color from a palette from our color brewer, you would use scale fill brewer, like here. Then we can also use this dichromat package to check how this plot with this color that we chose would look like for people with different kinds of color blindness. And so this is the palette that I created that was a little bit problematic. And we can clearly see here by using this scale fill manual, and then the values is dichromat of this palette with the type of color blindness that we want to check. This is how it would look like. And we can clearly see that this is actually problematic because these shades of green are actually similar. And so a person would not be able to differentiate between these two colors because they both look green. And so this is if we're using the palette that we created. If you're using a color from our color brewer, what you would want to do is simply like puts your our color brewer palette in the right format inside dichromat and scale fill manual. So it's the same thing. Here we can see this safe color that we picked from our color brewer friendly colors is good because these colors are distinguishable. There are also other palettes that you can find in packages like Dichromat, Color Blindness, and Viridis, and these have colors that are safe for colorblind individuals, and you can check them out using the Palettier package. And so basically what you would do is Palettier D or Palettier C with the package and then the palette, and you can access the colors. Palettier D is for discrete color palettes, and Palettier C is for continuous color palettes, and you can access these colors. You can also see them using plots, and so you can see them like this. Yeah, and you can check all these, you can check the documentation for these two packages, and you can also access the documentation for all the color palettes that you can access through R, and see how these would look like for individuals with different color blindness as I just showed you. Thank you so much for watching. I hope this was informative.